Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. In this video, I wanted to talk about the application load balancer in AWS and how it now supports IPv6 only for internet connected clients. Before we get into that, though, I wanted to briefly talk about StratusGrid. We're an AWS Premier Consulting partner. So if you have any AWS consultative needs, feel free to reach out to us on our website, stratusgrid.com. That's right here in front of me. You can click on this Let's Talk button up here. We also are an independent software vendor, or ISV for short. We have a software tool called Stratosphere, which is a FinOps tool that helps you to centralize all of your cost data and cost optimization findings. It's predominantly targeted at large enterprises with lots of child companies, as well as private equity firms that need to centralize their view of cost in AWS and cost savings opportunities. So if you're interested in that, check out the book a demo link over here, and we would love to talk you through a demo of Stratosphere and help you get it set up in your environment so that you can have some hands-on experience with it. So the topic for today's video is going to be, again, the application load balancer and having its IPv6 only listener facing the internet. So I wanted to point you over to the What's New at AWS page. You can just search on Google for What's New with AWS, and that should take you over to this page. And this is a really great resource if you are working with AWS on a regular basis. I strongly recommend kind of staying up to date with the latest and greatest announcements. I just happened to come across one. If we search for IPv6 in the What's New feed right here, you can see that the application load balancer just about 5 days ago now supports IPv6 only support for internet clients. Now, I'm connecting to AWS and other services using the Starlink service from SpaceX, and so I have support for IPv6 on my internet connection. You may not have IPv6 support at home on your internet service provider. So one of the things you want to do is just to check to see if you have IPv6 support. There's lots of different websites out there that can help you determine if you have IPv6 or not. One of the ones that I like to use is called ipv6.apifi.org. And that should show you your IPv6 address if you do have one available. I think that's what it's called anyway. So if we just do a search for it here, I believe it's API IFI or something like that. And so that should show you what your IP address is. Any case, what we're going to talk about is specifically the Layer 7 HTTP application load balancer. It used to be that you had to either have a IPv4 only application load balancer, or you could have a dual stack IPv4 and IPv6 application load balancer. But now with this new announcement, you can now provision an application load balancer that only exposes IPv6 to the clients that are accessing it across the internet. Now, on the back end, you're still going to have dual stack, so it's still going to be using IPv4 or IPv6 to hit the targets, the services that are actually backing the application load balancer. So keep that in mind, but you can disable IPv4 and just have IPv6 on the internet-facing side where the clients are actually accessing it. So we're going to take a look at how to actually set this up completely from scratch over here in our AWS account. So if you're interested, you can follow along in your own AWS account. And what we're going to do for starters is to go out to the VPC service. We'll just search for VPC here, and we're going to create a brand new VPC specifically for this purpose here. And we want to make sure that the VPC also supports IPv6. So one of the options that you'll have when you create the VPC is actually going to be to specify an IPv6 CIDR block that you can allocate to your VPC. So the easiest way to create a new VPC is just to go to the Create VPC wizard right here. I'm actually going to switch over to a different region because I've had some issues with the Oregon region recently, so I'll probably switch to US West 1 Northern California. All right, so now we're in the Northern California region here, and I'm just going to click on the Create VPC button right here. And what we want to do is choose VPC and more, because that's going to create the VPC, the subnets, the internet gateway, the NAT gateway, and all that kind of stuff for us here. So I'll just call this Trevor ALB test here. And then we want to make sure that we choose this option to allocate an IPv6 CIDR block. Otherwise, you won't have any IPv6 support in your VPC. So we want to make sure we choose that. Also for availability zones, because we're doing load balancing, we have to have 2 availability zones. We're also gonna have 2 public subnets and 2 private subnets. I am going to choose to have an application NAT gateway here, a NAT gateway, so that we can have outbound support for IPv4 from our private subnets. Otherwise, our private subnets would not be able to access the internet, so that's why we need the NAT gateway. There is also support for something known as an egress-only internet gateway. Essentially, what this is it's for IPv6 clients that are in private subnets here to have egress access out to the internet, but not have inbound or ingress access to those instances. And so the internet gateway allows for IPv6 outbound and inbound network access, but if you only need to have outbound access for security reasons, then you can use the egress only internet gateway instead. But I don't need that in this particular case. I'm also going to choose none for VPC endpoints because I'm not going to be using the S3 gateway feature at all. And for tags down here, I'm just going to plug in an owner tag of Trevor Sullivan so that my other teammates know that I was the one that provisioned this entire VPC here. So now we're going to create this brand new VPC, but we actually need to go over to the subnets and make sure that the subnets have been configured correctly. We want to make sure that the subnets have auto assign IPv6 address enabled. We also want to make sure that our route tables are set up for IPv6 as well. So we'll take a look at that in just a moment here once this is done creating. Or actually, we can leave that creating. And what we'll do is just kind of middle click VPC here to open up another tab with the VPC service. And then what we want to do is take note of the VPC ID right here. So it's 0492. We'll just grab the first few characters. We'll go over to subnets here, and then I'll filter the list of subnets for that specific VPC ID. So now I can see only the subnets that are corresponding to the newly created VPC that I just created. So for starters, let's take a look at the private subnets here. We'll go to actions, say edit subnet settings here. We want to say enable auto assign IPv6 address and go ahead and save that. Same thing for the second one. We want auto assign IPv6 address there. Also, I want to make sure that we do have IPv6 CIDR blocks assigned, and it looks like we do already have those thanks to the VPC wizard. Same thing for the public subnets here as well. And so once we've got the auto assign, let's also do that in our public subnets here as well. So we'll say edit subnet settings, auto assign IPv6 and IPv4. And then we'll go ahead and save that. And then finally, we'll do the same thing for the last public subnet here. So we'll say the edit subnet settings, auto assign IPv6 and IPv4, and go ahead and save that. All right, so the other thing that we want to check is our route tables. So what I want to do is go check my route table that is associated with my VPC right here. And as you can see, we do not currently have, for the private subnet here, we don't have a route out to the internet, and that's probably because the NAT gateway hadn't been fully configured. So if we just refresh here, you can see now we have that outbound route to the internet through the NAT gateway. So we'll just check our other private subnets here as well. Let's go ahead and close that notification. Go to private number 2. That's got zeros out to the NAT gateway there. Go to public here, and out to the internet should be through the internet gateway. Same thing for IPv6. You should see this route here that shows IPv6 traffic going through the internet gateway as well. So everything here is set up for IPv6 for both ingress and egress as far as the internet gateway goes. So for our private subnets here, what we're going to do is just set up an EC2 instance in one of the private subnets. We'll go ahead and install just a simple web application on that EC2 instance. And then we are going to provision an application load balancer in the public subnets here that uses IPv6 only in order to allow inbound access from our internet clients. And then we should be able to access that IPv6 endpoint using our local browser here. All right, so what we're going to do is head over to the EC2 console here, and we're going to launch a new EC2 instance. Then we'll get logged into it, and then we will go ahead and install a simple application on there. Typically, I like to use Nginx just as a really simple web server example, but you can really use any sample web application that you want to. All right, so here we are in the EC2 console now, and what we want to do is go over to instances, and then we'll just say, I want to launch a new instance. And I'll call this ALB, or Trevor ALB Nginx test. I'll go ahead and choose an Ubuntu AMI right here. I'll choose an instance type like, let's actually do an ARM-based instance type here. And then we'll choose a t4g.small here. And then what we're going to do for the key pair is just leave that with no key pair, and then I'll actually get access to it using AWS Systems Manager Session Manager so that I don't have to SSH directly into it. And then for the network settings here, what we want to do is put this into a private subnet. So we're going to choose our new ALB test VPC right here, and then I'm going to put it into either private 1 or private 2 subnets. We're going to disable auto-assigning a public IPv4 address, but we do want an IPv6 address here. So we'll have a private IPv4 address and just a standard IPv6 address, of course. And then for the security group here, I'll just choose the default security group, and we'll use the same for the ALB as well. Then for the disk here, I'll just choose a 10 gig GP3 disk right here. And then under advanced details, I'm going to choose for the instance profile here an IAM role called Trevor Dev Server, which allows me to connect the Systems Manager agent up to the Systems Manager endpoint so that I can access it using Session Manager. We can do a different video on that particular topic. And then for spot instances down here, I'll just choose the spot as a persistent request. And then for interruption, I'll just do stop. All right, so I think we are good to go to launch our instance here. So let's just click the Launch Instance button down here. And then we should be able to access this instance using Session Manager. So what we're going to do is go over to the Systems Manager service here and use Session Manager once this instance comes online in order to access a shell so that we can install probably the Docker engine and then just spin up a container using the Docker engine for Nginx. So what we're going to do is take a look at the Fleet Manager here. We're going to wait for that instance to come online and report into the Fleet Manager. As you can see, there it is. So it's been registered with Systems Manager. So back in EC2, the way that we can connect to it is to just right-click on it and choose to connect to that instance, and then go over to the Session Manager service, and then you can just click on the Connect button, and that will open up a new browser tab so that you can interactively manage this system here. So what I'm going to do for starters is to say sudo apt update, and then we'll install the Docker engine on here. So then we'll do a sudo apt install docker.io in just a moment here. So we'll say sudo apt install docker.io -- yes. And then after the Docker engine gets installed, we'll just spin up an Nginx container. So to do that, we'll just say sudo, whoops, let's let this finish here for a second. And then we'll do a sudo docker -nginx just to download the Nginx container image here. And then once the Docker Nginx container image has been downloaded, we can go ahead and launch one by doing a sudo docker run. We'll connect it to the host network so that we don't have to expose any ports. And then we'll say -- detach, and then we'll use Nginx here. So that should spin up a container. We should be able to also curl to that. So if we do curl localhost on port 80, we should see the HTML right here for the standard Nginx page. So now that we know that this service is up and running, what we want to do is provision an application load balancer that connects to this EC2 instance and load balances across, in this case, a single instance, but ideally you'd have, 2 or more instances to actually do load balancing across. So now our application has been set up. We also want to go to the VPC security group here. So if we go over to the security tab here, go to security groups, we want to make sure that we have inbound access to TCP port 80 from the same security group. And because we're going to be using the same security group for both the ALB and the EC2 instance, we should be allowing all traffic from that security group. So we'll go ahead and just leave that there. And then what we want to do is for the load balancer, go back to the EC2 console right here, and then we'll provision the target group, which is going to point to the EC2 instance's IP address. And then once we create the target group, then we can actually create the ALB and associate the target group with it. Great. So here we are back in the EC2 console, and what we want to do is go down to load balancing and then go to target groups here. Also, actually, before we do that, we want to make sure that we grab the instance IP address. So back under the instance details right here, we want to go to networking, and we want to find the IPv6 address of the instance so that we can register that with the target group. So back under target groups, we'll say create a new target group. And then what we want to do is specify some IP addresses. You could also do instances here, but I'm just going to hard code the IP addresses because that's how you would do it if you were doing something like Fargate containers, for example. So then what we'll do is for the target group name, call this Trevor ALB test. We also want to use HTTP as the protocol on TCP port 80. We're going to use IPv6 as our protocol or IP address type. We're going to choose our test VPC down here. And then for the health check settings, I'm going to bump these down to the minimums so that we get really quick responses here from the health checks for the ALB. Then for the tags right down here, I'm going to go ahead and plug in my owner, Trevor Sullivan tag, just so everybody knows that this was me that created it. And then down here, what we can do is plug in an IP address for that instance. And so then we'll say include as pending as down below. So now we have that target registered, and we'll hit create target group. Now, once we've created the target group itself, it's not actually going to be active until we create an actual load balancer. So if we check out the health of the registered targets, we're not going to see anything happen. It's just going to sit here and say unused until we actually add it to a load balancer. So as you can see, it says the target group is not configured to receive traffic from the load balancer. So because the target group is just sitting out there by itself, we need to go ahead and create a load balancer as well. So what we'll do is say load balancers, and then we'll say create a load balancer. We want to choose the application load balancer type right over here. And then for the load balancer name, I'll do Trevor-ALB-test. And we want to make sure that it's internet facing, right? We want external clients to be able to access this. And then right down here, this is the key part that has changed in the announcement that we looked at previously. So we could do IPv4 only to external clients. We can do dual stack so that it has IPv4 and IPv6 addresses, or we can say dual stack without public IPv4. And so what this is doing again is it's using dual stack on the back end to communicate with EC2 or Fargate or any other services that may be running. But on the front end, where the internet clients are actually hitting the ALB, it will only have an IPv6 address. So that's the option that we want to choose. Also, I believe based on the announcement, you can change that setting after the fact. So if you do provision it as dual stack, you should be able to change it to dual stack without public IPv4. So on the network configuration, we're going to choose our VPC. We're going to choose our public subnets here to expose it to the internet. And then for the security group down here, we'll just use the same default security group. And then for the target group here, we want HTTP port 80 on that IPv6 internet-facing address to forward to the target group that we just created. So that's going to load balance across all the targets that have been registered into that target group. And then finally, we can go ahead and just choose the button down here in the bottom right that says create the load balancer. Now, the provisioning process for an application load balancer is going to take just a couple of moments to complete. So go ahead and be patient while that happens. But the other thing that I'm going to do is to actually check out the VPC security group so that we have access to the ALB. So what I want to do is go down to my VPC and find the VPC ID with 049. I want to go to inbound rules here. And what I want to do is make sure that I add a new inbound rule that allows IPv6 clients to access it. So what we'll do right in here is just say add rule, and then we're going to create a custom TCP rule for TCP port 80. And then what we want to do is say that anybody on the internet, so /0 IPv6, should have access to HTTP port 80. So let's go ahead and save that rule. And then once the load balancer has finished creating over here, we should be able to access it directly across the internet by using the DNS name that you can see right here. And this should be a quad A DNS record. So if we drill in here under DNS name, you should see that this is a AAAA record, which indicates that it's actually an A record, but specifically for IPv6 rather than IPv4. And so because we don't have an A record, we don't have IPv4 connectivity to the internet-facing endpoint for the application load balancer. Let's give this just a moment to finish provisioning, and then we'll come back and we should see under the resource map right down here. The resource map is really nice because it can actually show us the health checks of our registered targets here. So you'll see target registration is in progress until it becomes healthy, at which point we should see it turn healthy right here. And if I refresh, sure enough, you can actually see that that just happened a moment ago. So now what we're doing is waiting for the status to be active right here, which it did just change. And so now what we're going to do is copy this quad A DNS record right here. We'll open up a new browser tab. And after just a moment here, we should get the Nginx landing page that we received when we curled to the local EC2 instance. So as you can see, there's our welcome to Nginx page. And so we are accessing it over IPv6. The other way that we can validate that we're using IPv6 is to open up the Chrome browser tools here with, what is it, F12, I think, or Control-Shift-I is the other keyboard shortcut that you can use, or if you're on Mac OS, you can use Command-Shift-I. And so what we want to do here is go to the Network tab, and then if we refresh the page right here and then come back to the Network tab, let's close this bottom section, let's open up this request right here. And what you can see is that the remote address that we are connecting to right down here is, in fact, the IPv6 address of the application load balancer. So that DNS endpoint, that quad A record, resolved to this 2600 address right down here. So that confirms that the browser is indeed accessing the ALB over IPv6. There simply isn't an IPv4 address allocated to the load balancer. So we know that if we're hitting this landing page here, we are accessing the ALB over IPv6 rather than IPv4. So now we should be able to change that in theory. So if we say edit IP address type, you can see that we could now change it from dual stack without public IPv4 to just standard dual stack, or we could actually remove the IPv6 address and tell it only to use IPv4 addresses instead. But remember that the target group that I configured is actually using an IPv6 address to access the EC2 instance privately. So you'll want to keep that in mind if you're changing the IP address type here. Make sure that you register your target groups with IPv4 instead of IPv6. All right, so that's pretty much everything that I wanted to cover here as far as setting up the new IPv6 only application load balancer that was just released on May 16th of 2024. Thanks so much for joining me in this video. I hope you learned something new. Make sure you leave a like on the video, leave a comment down below, and let us know what you thought of this video and any other AWS topics that you're interested in seeing on the Stratus Grid YouTube channel. Thanks again, and we'll see you in the next video. Take care.